Good evening, everyone. Thanks so much for spending your Monday, right? Is it Monday? Yes, it is. With me tonight. And thanks, Name, for inviting me to speak. I'm so excited to talk to you for an hour about my favorite marine mammal, sea otters. Thanks, Fawn, for the wonderful introduction. My name is Chanel Hason, and I'm the Director of Outreach and Community Relations for the Elakha Alliance nonprofit. Just a little overview of my background, which you heard a little bit from Fawn already, but my passion for ocean conservation started when I was that little girl in the photo at SeaWorld and seeing all the animals up close and personal. And I really wanted to work with animals, marine mammals. I went to Cal State University, Monterey Bay for my undergrad in environmental science, technology, and policy, focusing in marine and coastal ecology. Volunteered at the Monterey Bay Aquarium with the sea otters, river otters, and the sleepover campins. And then I was able to study abroad in Australia, do marine science research on the Great Barrier Reef, and realized after those several years that one, I wasn't necessarily really thrilled about doing marine science research, and also training marine mammals was not my end goal in life. So instead, I kind of switched gears and went towards education, environmental science education. And in between that time, I was randomly chosen as a finalist for the Miss Scuba International pageant. So I went to Malaysia. It's a scuba diving beauty pageant. Who knew? And so I represented the US there. Won three titles, pretty good for somebody who hates heels, and the only marine biologist and rescue diver there. Then I moved immediately to Puerto Rico and worked as an eco tour guide for Jean-Michel Cousteau's Ambassadors of the Environment program. And that's when I really solidified having my master's in education and moved to Portland 10 years ago and went to Portland State University. And ta-da, here we are today. And so I've been working for Elakha Alliance for the last 5 years. I was the first ever employee, and now we have a wonderful full-time staff of four all over the state of Oregon. So that's a little bit about me. Now, let's dive into our topic today. We're going to talk a little bit about sea otter biology, and then switching gears to estuary and kelp forest ecology. And then we'll talk a little bit about the past, present, and future of sea otters here on the Oregon coast. And I would love it if anybody wants to put in the chat where they're tuning in from. And if you have a question that comes to you while I'm talking, you can put it in the chat and we'll get to it after I finish the presentation. So you don't lose that thought. Okay, so let's talk about sea otters. They are part of the Mustelidae family, which is the weasel family. They're related to wolverines, badgers, minks. There are three subspecies. So there's the northern sea otter, which are found in Washington, British Columbia, and Alaska. Then we've got the southern sea otter, which all make their home off of the coast of California. And then we have the Asian or Russian sea otter, which are based in Japan and Russia. Um, these are the only otter species out of 14 that are fully aquatic. Every other otter species is semi-aquatic. They swim and eat, they sleep, they do everything while they're floating in the ocean. They live about 10 to 20 years. Usually in captivity, they live a little bit longer. Also, females tend to live longer than males in the wild. They like to aggregate in floating rafts, usually by sex, so female and male rafts. And they're not a migratory species, so they really stick to wherever they were born and have a really strong site fidelity. So sea otters lack what every other marine mammal has, and that's a thick layer of fat. So instead, they are equipped with the world's densest fur on the entire planet. They have up to Ba-da-dum, 1 million hairs per square inch. And if you're like, what's the size of a square inch? If you do the OK symbol with your hand, that circle is about 1 square inch. So, for example, on our human head, we have about 100,000 hairs if we're lucky. So, in comparison, sea otters have such a thick, dense fur, and that is how they keep warm in the cold waters that they call home. And so they actually have two layers of fur. They have an underlayer and a guard layer. And so when they're constantly grooming themselves, they're actually putting pockets of air in between those two layers of fur. And that's kind of what's keeping them warm. And so when they dive down, those you can see them if you're at a zoo or aquarium, if you're watching a documentary, all these little bubbles are leaving their fur, and that's kind of like their warmth jacket is leaving them. So then when they resurface, they have to constantly groom and put that pocket of air in between those two layers of fur. And pretty neat is that that bottom layer of fur never actually gets wet. So it's pretty incredible. So sea otters are eating machines. They are constantly snacking if they're not napping or grooming themselves. So a 70-pound sea otter needs to eat about 20 pounds of food every single day, which is about 3.6 tons per year. They are usually the most expensive animal to feed at a zoo or aquarium. The Oregon Coast Aquarium, I was just there the other day. They said it costs about, I think, $2,000 a day to feed them. Don't quote me on that. But they eat the highest quality seafood when they're at a zoo or aquarium, so they are eaten well. But in the wild, they eat about 100 different crustaceans, including sea urchins, crabs, mussels, clams. Sometimes they can grab an octopus or a marine worm. They are highly intelligent creatures, so they are one of the only marine mammals to use a tool. So oftentimes they will use rocks to as sort of an anvil. They'll put a clam on their stomach and then smash it open with a rock. Sometimes they use sedentary rocks that they can just smash up a clam against it or a crab, but they're highly intelligent and have a really fast metabolism. So one of my favorite things about sea otters is that they have these short, blunt skulls and fracture-resistant teeth. Their enamel is about 2 times stronger than human teeth, and they have the same bite force as a black bear, which is about 80 pounds. So they have a really strong bite, and it kind of makes sense if they're eating all these hard-shelled invertebrates every single day. But they are the epitome of you are what you eat because they eat so many purple sea urchins that it actually turns their bones, their teeth, even their vertebrae purple. And it's called echinochrome staining. And so that happens when they eat these purple sea urchins. So it's kind of like when humans eat too many carrots, it can turn their skin orange. So it's kind of similar to sea otters and the purple urchins that they like to eat. So unfortunately, there are some threats to sea otters. So we've got predation by white sharks, although they don't necessarily eat sea otters. When they're transitioning from juvenile to adult white sharks, they're eating fish to marine mammals. They often mistake sea otters for what they're really trying to get, which is a seal or sea lion, which has all that fatty blubber that they want to eat. But then they get a mouthful of hair when they take a bite of a sea otter and no fat, and they're like, gross, and they let go. And unfortunately, that's pretty fatal for the sea otters. There are some whales, orcas in Alaska that are pretty well trained with eating sea otters. There was one orca a couple of years ago who washed ashore deceased, and she had 6 sea otters in her stomach and one that was stuck in her throat, and so she suffocated because of that. Um, and then there's some human caused threat issues. Obviously, oil spills are extremely detrimental to sea otters. If they get that oil on their fur, which is their warm coat, then they start grooming that, then they're ingesting the oil, and it's super deadly for them. Obviously, plastic pollution is an issue, ocean acidification in their kelp forest ecosystems. And also, there is a bacteria in cat feces. So that's why there's a cat there. It's called Toxoplasmosis gondii. And so that washes ashore when it's raining and gets into the ocean. And then that causes a lot of neurological problems for sea otters, mostly off the coast of California. So for me, I get tons of questions about river otters and sea otters and what the differences are. So I want to go through how you can tell the difference because we have a lot of North American river otters here in Oregon, which often get mistaken for sea otters. So river otters they're kind of like a long torpedo of a body. And the best way to really tell the difference between sea otters and river otters is to look at their tail and look at their feet. So river otters, their tail, excuse me, is pretty much the same, double their body size. And so they have webbed paws, feet, which are really agile for running along the beach, running on rocks, digging their dens. They live on land. They're smaller than sea otters, so they're only 15 to 30 pounds. They swim on their stomachs. They do forage and venture out into the ocean. So oftentimes, if people see a sea otter or an otter in the ocean, they think it's a sea otter, but sometimes it can be a river otter. Um, and yeah, they have multiple pups a year, so they're usually seen in groups of 3 to 4. And now let's talk about sea otters. So sea otters are slightly bigger. They're about 50 to 100 pounds, and they're usually always floating on their backs. And they've got these really big back flippers, which helps them propel through the water. And you can see their tail with the one standing there. It is pretty much almost the same size as their flippers. So it's a pretty short tail. So that's why I said that one of the big differences between the two are between river otters and sea otters are their tails. And sea otters rarely come on land. That's because they live the majority of their life in the ocean. Sometimes they do haul out on rocks to sunbathe or groom, or maybe they're sick, but it's very rare to see them come out on land. So now that you are all experts to tell the difference between the two, let's watch a little video. So, which one do you think these are? These are sea otters. And now these are river otters. Look at those long tails. These are all at the Oregon Zoo. They really love their hard-boiled eggs, just like me. And here you can see the sea otters getting an oyster and then using that rock as their tool. Pretty neat. And you can see why the otters at the Oregon Zoo are some of the most favorite animals on their social media pages. Okay, here we go. Okay, let's switch gears a little bit and talk about sea otters and their role in healthy estuaries. So, since we don't have any sea otters in Oregon, if you didn't know that, we will go to the Elkhorn Slough in California that has plenty of sea otters. It's one of California's largest and most significant estuaries. It's right near Monterey Bay. It provides a really rich habitat for diverse wildlife, including over 340 species of birds, sea otters, fish, and other invertebrates. If you've never been there before, I highly suggest putting it on your wildlife bucket list. It is a really beautiful place that you can get very close but safely from a distance to all these fantastic animals and wildlife. So, one researcher in particular, Dr. Brent Hughes out of Sonoma State University, has been the front runner in discovering the interconnectedness of sea otters and estuary health. So, his research discovered that sea otters play a really crucial role in supporting eelgrass health in the Elkhorn Slough by controlling populations of crabs and other invertebrates that feed on small organisms like sea slugs, which help keep eelgrass free from harmful algae. So basically, in easy terms, without sea otters, crabs overpopulated and ate all of the sea slugs. And without the sea slugs eating algae that's growing on these eelgrass blades, then that algae is covering that eelgrass. And when grass is covered by something, it can't photosynthesize and thrive. So when sea otters came to the Elkhorn Slough, they ate all as many crabs as they could, which allowed the sea slugs to do their job because they're not being eaten. And this allowed the eelgrass blades to be nice and clean, which helped the entire ecosystem overall. So eelgrass is a plant and it also sequesters carbon, so it's a big carbon sink and provides very crucial habitat for numerous animals. And so Sea Otters made the cover of Nature magazine, their modeling debut in 2024, with another research discovery from Dr. Brent Hughes and his team. And so they discovered that otters eating marsh crabs in particular, which would otherwise burrow into the soil and eat the plant roots. And so these crabs destabilize the marsh, contributing a lot to erosion. And so by controlling the crab population, sea otters allowed the marsh vegetation to thrive, and this leading to stronger root systems to protect against erosion. Sorry. In areas where sea otters have returned, erosion has been reduced up to 90%, which is huge. And so another recent study that he published showcased how their hungry appetite for crabs, including European green crabs, is having a big impact. And so European green crabs are very invasive on much of the West Coast and also in Oregon. And so he determined that one sea otter, southern sea otter, can eat between 50,000 and 120,000 European green crabs annually, which is huge because these European green crabs compete with other native species in the ecosystem. So having something that can eat that is a pretty positive plus. So when you have sea otters in estuaries, then you have a winning equation. So you've got improved water quality. It helps stores carbon, as I mentioned before. It's a safe haven for hundreds of migratory birds. It decreases erosions and has great habitat for juvenile salmon and fish. And that also means you have increased biological productivity. So now let's jump into another ecosystem. So we are now swimming through the kelp forests of Monterey Bay. So kelp forests comprise about 25% of the world's coastline from California all the way up to Australia or down to Australia, South Africa, and Central America. They are one of the ocean's most diverse ecosystems. There are many fish that use kelp forests as nurseries for their young, while large megafauna marine mammals like sea lions, seals, sea otters, and gray whales use them as a protective shelter place from storms. And kelp forests thrive in cold, nutrient waters. And although kelp looks like a plant, it's actually a large brown algae, which relies on photosynthesis, and which is why it grows really tall and makes these beautiful sort of cathedrals underwater as they're trying to reach the surface to get that sunlight. So let's talk about the structure of kelp themselves. In Oregon, we mostly have bull kelp, which is the one featured there on the left. So as I mentioned, they are not a plant, so they don't have root systems that suck up nutrients. Instead, they have something called a holdfast. So think of it as kind of like a hard, sticky spaghetti. So they're looking, when they're a baby kelp, they're looking to settle on a rocky, hard substrate. So they find that rock, they settle down, that sticky holdfast holds on tight, and then they grow a stipe because they're trying to get to the surface of the water. And then for the bull kelp, they have a gas-filled bulb called a pneumatocyst. And then from that bulb, there's about 50 to 100 blades that are trying to photosynthesize at the surface. On the other hand, we have giant kelp, which is actually the fastest growing algae in the world. It grows about 2 feet a day. Meanwhile, bull kelp grows about 1 foot a day. But on the right-hand image, you'll see the structure of giant kelp. So instead of having one bulb and many blades at the top, instead they have numerous bulbs and one blade per each bulb that goes all the way up to the surface. So bull kelp grows about 100 feet, and giant kelp can be about 200 feet tall. So, underwater forests are one of the most incredible ecosystems on the planet. They're biodiversity hotspots, so they provide shelter and food for a wide range of marine species. Excuse me. And they also store carbon, so they absorb carbon dioxide, which I'll talk about some more in a second. And they also protect coastlines. So they act as natural barriers, reducing wave energy and preventing shoreline erosion. And through photosynthesis, they produce oxygen, both for life underwater and on land. They support fisheries that are harvested for sustainability, for products, for food and different things. And then they also maintain healthy marine environments by regulating species populations and nutrient cycles. So, like I mentioned, kelp helps fight with climate change. By some measures, underwater forests and eelgrass beds can sequester about 20 times more carbon per acre than terrestrial forests do. And here in Oregon, especially, kelp forests play a really crucial role in supporting gray whales off of the coast of Oregon by providing habitat and essential prey like krill and mysid shrimp that they eat. And these ecosystems also serve as a protective environment, offering shelter and feeding grounds for these whales while they're going up and down the Pacific coastline. And unfortunately, studies indicate that gray whales in the Pacific Coast feeding group have decreased in size by over 13% in the past 2 decades. And so whales born in 2020 are expected to be significantly smaller than those born before 2000, which may lead to reproductive health challenges and signal broader ecosystem issues. Researchers don't really know what the direct cause is, but it's most likely environmentally driven changes could be a factor to that. As a visual learner, I really like this graphic about the kelp and carbon cycle. So, how does kelp actually store carbon? How does that all work? So, let's start from the beginning. Kelp uses sunlight and carbon dioxide, CO2 from the water during photosynthesis to grow. And this process helps remove CO2 from the atmosphere. And then, as kelp grows, it stores carbon in its blades, stipes, and holdfasts. And then when animals eat the kelp, the carbon stored in it moves up the food chains, supporting other marine life. And then when kelp dies, hopefully it floats out into the open ocean, sinks down to the bottom of the seafloor, and gets trapped under the sediment for hopefully thousands of years. And then the cycle continues. Sorry, my cats are being naughty behind me, trying to get into something they're not. Okay, so thankfully, thanks to Dr. Jim Estes, he did some groundbreaking research, and we know now that sea otters are a keystone species. And so I really like to show these photos by Ralph Pace, a really wonderful photographer in Monterey Bay of sea otters underwater in their natural habitat in the kelp forest, because one, it is very hard to photograph sea otters underwater because they are very fast, and two, it's also illegal to get this close to them. So thankfully, Ralph had a permit through U.S. Fish and Wildlife Service to capture these for research purposes. So, what is a keystone species? Many of you may already know that, but I'll tell you for those who don't. Sea otters are what are known as a keystone species. So, basically, they have a large impact on their environment relative to their abundance. So, a small handful of sea otters has a really big impact on the overall health and biodiversity of an ecosystem. And so here's another great graphic that showcases what a kelp forest would look like with sea otters present. So they control the urchin populations. And when sea otters are missing from that ecosystem, then there's an imbalance in the predator-prey scenario. The sea urchins overpopulate. Sea urchins eat kelp. And so when you have too many sea urchins eating kelp, then that can destroy entire acres of kelp forests. That is what is occurring along much of the western Pacific coastline. So, which is one of the big reasons we are working to bring sea otters back to help restore balance. Speaking of this, let's talk about Oregon and what we have going on here. So we have two types of sea urchins here in Oregon. We have red and purple. The biggest difference is their size and color. So red urchins, if you open your hand, they can be about the size of a basketball, so they're about that big. And purple sea urchins are about the size of your fist, so they're quite smaller. They eat kelp and algae, decomposing creatures, all the yummy things. And a fun fact about red sea urchins is that scientists have found one that was 200 years old. And that's just the oldest specimen that we found, so they may live even longer. Along those lines, sea urchins never stop growing. They just grow very slowly, only about 1/100th of an inch per year after they reach adulthood. And they're very sensitive beings, so sensitive to pollution, that is. So they're great water quality indicators because if they can't thrive in areas with significant water pollution, we know if something bad is happening to the sea urchins. There's probably some environmental factor for that. So sea otters have been absent off of the Oregon coast for over 100 years. And so while they've been absent, there's been another key predator in the ecosystem kind of keeping those sea urchins at bay, and that was the sunflower sea star, the largest sea star species with over 24 arms photographed here. Until, unfortunately, a series of unfortunate events happened. In 2013 to 2015, there was something called the blob, which was a really big marine heat wave. And so this caused temperatures to rise almost 3 degrees Celsius above normal, which may not seem a lot to us, but for, small animals and invertebrates in an ecosystem, that has a really big impact. And so something called sea star wasting disease started occurring. So basically, sea stars started to melt apart. Their arms would just dislodge from their body and walk away from them, and they just kind of eventually turned into goo. But it took about 10 years to figure out exactly what sea star wasting disease was caused by. And so we know now, thanks to University of Washington students, researchers, it's a strain of bacterium called Vibrio pectinacida. And so that pathogen also causes cholera, and affects coral and shellfish. So now we know that. There are different groups working on growing sunflower sea stars in labs to reintroduce them into the wild. So now that we have figured out what this bacterium is, perhaps they can have a better likelihood of surviving if there still is some or sea star wasting disease out there, that they can be immune to it, perhaps. So unfortunately, that was about 90% of the overall sunflower sea star population was decimated by this disease, and they haven't bounced back as quickly as some of the other sea star species. So in Oregon, the Oregon Kelp Alliance recently released an Oregon kelp forest status report. So from the years 2010 to 2022, they had kelp forest survey data. And so here is a quick summary of that. So unfortunately, about 2/3 of our kelp forest coverage has decreased statewide. There are some sections that have increased, so that is positive. But there is just not a lot of kelp forest cover as there once was historically. But there is enough kelp forest cover for sea otters to be reintroduced in, which I'll talk about in a second. So what does that look like? So on the left is a healthy kelp forest, and on the right is what is happening along our coastline. So they're called urchin barrens. So basically, if you just look down in the bottom of the water column, you'll see just a carpet of spiny purple, and they're just devouring kelp because they don't have any predators. And so this is a huge problem. There's an estimated about 350 million urchins on one single reef in Southern Oregon alone, and that estimate was about like 7 years ago, I think. So it is a huge problem. And so something really negative about this particular invertebrate is that they just don't die. They can live a whole year without ever eating anything. They go into a zombie state. So they're referred to as zombie urchins. So where kelp forests have declined so much that they don't have really any food, they enter this survival mode. So they stop reproducing. They slow down their metabolism a lot, and they'll just continue to graze if anything falls down to the bottom of the seafloor for them to eat. So this is also a big problem because their numbers are just continually high because they can survive for so long without eating anything. So now let's shift gears a little bit and talk about the past, present, and future of sea otters here on the Oregon coast. So, a very simplistic timeline of sea otters. So, about 2 million years ago, sea otters evolved near somewhere near modern day Russia, and their population was the from Baja, Mexico, all the way up to the North Pacific to Russia and Japan. And then about 10,000 years ago, Native Americans arrived to the Pacific Northwest, and sea otters and Oregon coastal tribes became one integral part with each other. There's locations in Oregon today like Otter Rock and Otter Point, which are direct translations of names given to these places by indigenous people. About 150 years ago marked the end of the maritime fur trade, which began in the mid 1700s, which we'll talk about in a little bit. But unfortunately, about 99% of the global population of sea otters were killed during that fur trade. And about 55 years ago, there was a series of translocations, and one of those was in Oregon. And we'll talk a little bit about that. But that was the last time we did have sea otters on the Oregon coast. So I really want to chat a little bit more in depth about the indigenous importance of sea otters on the Oregon coast. So there's at least 6 different words for sea otter in 8 different indigenous languages. And so you'll see that first one, the Chinook word, Elakha, is the name of our nonprofit. So I'll talk about how our name came to be in a couple more slides. But yeah, there's stories passed down from elders of sea otters intermingling with indigenous people on land, and they wore their pelts as regalia as well as very valuable. And something really important on the Oregon coast is that sea otter bones found in shell middens showcased that there are both northern subspecies and southern subspecies of sea otters found on the Oregon coast. So in the future, this might be really crucial to help the genetic diversity overall of the entire species of sea otter if we brought them back to the Oregon coast again. So the maritime fur trade we kind of touched upon. So the Chinese really valued sea otter pelts, and so Russian, Spanish, British, and US mariners decided to come to the Pacific Northwest, especially to hunt these sea otters for their very valuable pelt. Unfortunately, indigenous peoples were enslaved by these mariners to hunt sea otters because they knew how to do it because it was part of their own practices. The last sea otter pelt was traded in 1910 based on an article in the Coos Bay Times paper, and that was the last known evidence we have of a sea otter pelt traded on the Oregon coast. And it went for $500, which I believe is about $50,000 in estimated money today. So I said 99% of the global population of sea otters was extirpated, and that meant there was 1% that did survive. So thankfully, there's about an estimated 2,000 total sea otters that survived the fur trade. They were in little small remnant populations. And so you can see the area in black is their native range of sea otters historically, and the red dots are what survived. And so there was a tiny pocket off of the coast of California in Big Sur of about 50 sea otters that survived the fur trade. And then there were several remnant populations across Alaska and in Russia too. So where are sea otters today, and how many are there? So in California, there's about 3,000. Remember, those are all the southern subspecies coming from those surviving 50 of the fur trade. So their genetic diversity is super low. Then in Washington, they were reintroduced in the 1970s, and now they have about 3,000. British Columbia has about 8,000. Alaska is the home to 90% of the global population of sea otters, so they are about 100,000. Japan has the lowest amount. They have about 50 right now. And then Russia has about 18,000. So let's talk about the translocation that happened here in Oregon, but also happened in not only Oregon, but Washington, British Columbia, and Southeast Alaska. So sea otters from Amchitka Island were being translocated because the US government was doing nuclear bomb testing on this island. And so researchers had to really act fast and get some funding solidified in order to save as many sea otters as they could. So nearly 100 animals were released at Cape Arago, 40 animals in 1971, and in Port Orford, there was about 29 animals in 1970 and 24 released in 1971. I want to mention that none of these sea otters were tagged. I didn't start tracking them until a year after they were released. So there's not that great of data on where they all swam to, but they appeared to have left soon. As I mentioned before, they have a really strong homing mechanism, site fidelity, so many of them probably tried to swim north to Alaska, where they came from. They may have ended up in the Washington population that was reintroduced there. But they did survive for about a decade and have pups, but eventually their numbers dwindled and they all disappeared. And so researchers think they just didn't release enough animals initially to withstand natural immigration and mortality rates that happen during a wildlife translocation. And so nowadays we have way better translocation methods, research, understanding about these marine mammals, and we're doing a lot of research prior to the translocation to figure out the best possible locations based on all the data that we have. So I'll talk about that too in a second. So let's chit chat about the Elakha Alliance, our wonderful nonprofit. So we became officially a nonprofit in 2020, but before that, we were the idea of the late David Hatch, who you see there on the left. He was a Siletz tribal member, and he was building a boat with his son Peter and came across the word Elakha in a Chinook trade jargon dictionary to name his boat. He's like, huh, sea otters. Why don't we have sea otters in Oregon? Where are they? What happened to them? And so that led him down to several decades of questioning and talking to researchers and scientists and other tribal members to figure out if it was feasible to bring sea otters back to the Oregon coast. And so, unfortunately, he passed away unexpectedly in 2016. But the group of people he influenced with his passion got together, created a board of directors. And like I mentioned, we became an official nonprofit in 2020 to help live out David's dream. And so we're a small but mighty team of 4 full-time staff. 2 of us are in Portland, and one's in Eugene and one's in Coos Bay. We have an incredible board of directors ranging from a wide variety of backgrounds, working really hard on our mission, which is to make Oregon's marine and coastal ecosystems and communities more robust and resilient by restoring a healthy population of sea otters to the Oregon coast. So I know sea otters are pretty cute to look at, but really the goal and mission of a sea otter reintroduction is to have a big impact, positive impact on restoring our coastal and marine ecosystems and also bringing back that cultural significance for our tribes. So we are really rooted on getting the science right. So in 2022, We published a very beefy scientific feasibility study. We hired the top six sea otter scientists across the globe to figure out is it even feasible to bring them back to the Oregon coast. And big news, yes, it is feasible. So here are some of the key takeaways. So past reintroductions have been very successful for sea otters, just minus the Oregon one we talked about. But I'm very hopeful that a future one would be different now that we have way more information and research under our belts. And reintroducing them to Oregon is likely to succeed if done carefully, obviously. Estuaries may be a key place for a reintroduction location besides kelp forests. And there's still some information gaps that we figured out from this feasibility study, which is what we've been working on, finding that information over the last several years. And also in 2022, U.S. Fish and Wildlife Service published their own feasibility assessment on sea otter reintroduction in Northern California and Oregon. And they also said, yes, it is biologically feasible to bring them back and could have significant benefits for marine ecosystem health. However, they have not taken a position on whether to move forward. But this was a huge positive step in the right direction. So, what are our next steps? So, obviously, here today, doing outreach and public engagement is really important to get people informed about why they should care that sea otters are missing on the Oregon coast. And we are ramping up our political support a little more since the past couple of years, and also increasing our tribal engagement and filling in those research information gaps highlighted in our feasibility study. Like I mentioned, for example, we worked with a big fish lab out of Oregon State University to figure out where white sharks hang out on the Oregon coast. So we funded that. That QR code goes to our action alerts on our website. So if you are Oregon based, you can click that or scan that, and that will take you to two action alerts that can easily send information to your legislators to let them know that you care about wildlife. And so we were really focused working with U.S. Fish and Wildlife Service on a reintroduction until this current administration. And so now we are switching gears a little bit. And now we're really focused on a tribal and state-led effort. So working with the tribes and Oregon Department of Fish and Wildlife Service on a reintroduction plan. So thankfully, last year, the Confederated Tribes of Siletz Indians submitted a full proposal under the America the Beautiful Challenge grant, and they were awarded $1.56 million to lead a planning process for the reintroduction of sea otters to the Oregon coast and Northern California coastline. And this is huge. And thankfully, it did not get blocked. Federal funding did come through for this. It took about a year paperwork last year, but it is finally got the green light. And we are hiring a reintroduction planning manager. Actually, today is the final day you can submit for that, but we worked with them as one of the partners and recipients of this grant. So over the next 3 years, we will work with the tribes in Oregon and Northern California to increase tribal capacity to really focus on writing a sea otter reintroduction plan and coordinate with a lot of different stakeholders. And hopefully within 3 years after that, we'll have a coordinated plan document for reintroduction. Another really positive thing that happened last year in 2025 was that the Wildlife Conservation Network, which connects really wealthy donors with very wonderful wildlife conservation nonprofits around the globe, launched a Sea Otter Fund. So they're trying to raise $42 million in 12 years for sea otter restoration along their historical U.S. Pacific coastal range. And this is important because if we have private funding to help fuel a sea otter reintroduction process, that increases the likelihood that the government would accept that. And uh, and we would have money to do a reintroduction. And so this is not a out of the blue number. This is the estimated costs that U.S. Fish and Wildlife Service put in their feasibility assessment on reintroduction. So this is also very positive news moving forward. So how can you help? We would love if you wanted to stay in tune with what our efforts are. You can sign up for our monthly newsletter, The Raft. It comes from me. If you sign up now, you'll probably get it tomorrow. Um, and then we are a nonprofit, so donations are always very helpful. There's also a little QR code. We have a really great kelp forest sea otter coloring page for kiddos. And also, since I am talking to some educators, if you are a teacher and you would like me to present to your class or one of my colleagues, you can use that QR code as well or shoot me an email. We would love to help spread the word. We are on every social media platform, so if you are on there and just would like to see some sea otter content on your feed, especially nowadays, feel free to follow us, give us a like. You can also get to our website by simply typing OregonSeaOtters.org. Our YouTube channel is packed full of amazing presentations from scientists all over the globe. So if you really want to take a deep dive one weekend, on sea otters and kelp forests and all that good stuff, head to our YouTube channel, Elakha Alliance. So we are an alliance, which means it's not just us. So thankfully, we have some incredible partners all over the world who are working to help us bring sea otters back to the Oregon coast. So just want to give a shout out to them and thank them for their work. And so I want to mention that sometimes we do have lone male sea otters spotted along the Oregon coast or that wash up already deceased. This was 2 years ago. I got an email that there were maybe sea otters off of Cannon Beach in Oregon. And usually 9 out of 10, they're always river otter sightings. So I was like, if you can give me a photo, that'd be great. Sure enough, I got a photo and I was like, that is definitely a sea otter. So I was freaking out and drove out the next morning with a volunteer who spotted them. And we went out, and sure enough, there were two male sea otters out there, which I think this is the first time that two live ones were ever seen off of the Oregon coast. So that was pretty amazing. These male sea otters from Washington are coming down looking for some lady friends. Unfortunately, we don't have any of those quite yet, so they don't stick around very long, and they often just swim back where they came from, or sadly, sometimes wash ashore with a shark wound bite. But here is a photograph I got of one of those otters that was seen across a lot of news platforms during that time. And yeah, a nice little message of hope for a hopeful future of sea otters back on the Oregon coast. And that's all I have for you. So we can now jump to some questions.
All right, awesome. Thank you so much, Chanel. That was amazing.
Yeah.
We're always learning something new. It's just awesome. So the first question we have over here in the chat, and I see another one has popped up, but from Sarah McGregor from Victoria, BC. In terms of crabs, they eat in the estuary systems. Is there evidence for them having preferences of invasive or overpopulated crabs over other species that may have been more rare or have more positive ecosystem function? I guess I just was wondering is I understand they tend to be more generalist predators, but do certain populations exhibit different food preferences due to learned behavior that could make them more or less likely to consume species of concern?
Yes. What
Two
a juicy question.
questions.
Um, Yeah, so I didn't mention this during my talk, but sea otters learn how to forage and eat from their mom. So usually what their mom ate is what they tend to be really excellent hunters for. And so for the crab question, it could just be, oh my gosh, sorry, my cat is screaming at me. Let's see if he wants to make his presentation debut. Um, this is Benny, everyone. Uh, so yeah, it could just be there were so many European green crabs that were invasive in the Elkhorn Slough that they outcompeted the native predator or the native crabs, and so then sea otters just started eating them at an alarming rate because they were overpopulating. So I guess it's not a simple yes or no question answer. Um, but somebody I know kind of joked that if we were to translocate sea otters back to the Oregon coast and we had them in floating tanks before, or floating pens before we released them, that we would feed them European green crabs so they got the taste and they knew what they were. But that is not confirmed for what's going to happen. So I
Or
hopefully
if
that
you
helped
put 'em in,
answer.
yeah, or if you put them in a floating pen with the urchins, just saying.
Yeah.
Okay, then Dennis White has the image about sea star wasting suggests that Vibrio pectinacida
hmm
is related to the blob. Is that thought to be the origin? If so, what is the mechanism that made it present there?
Yeah, so there's still a lot of unknowns. They think that the heat wave may have caused an imbalance in the ecosystem, and maybe that caused the bacterium to become more present. So they're still doing some research. It took them a decade to figure out what that bacterium was, so there's still a lot of research to be done. So I don't have the answer for you, but hopefully we will, thanks to some really hardworking researchers out there.
All right. Anyone else have any questions? You can just at this point, open up your mic and um, we can. If you want to close the um, PowerPoint, that
Uh-huh.
way we'll be able to see that. There we go. And that way, if anybody has any questions, if you'll just undo your mic or wave.
Sarah, I see your question. So in terms of current research you have done, what are the current thoughts of what numbers would be required? Great question. Oh my gosh, Benny, stop yelling at me. Um, so part of our feasibility study, Dr. Tim Tinker was the lead author for that. And so he is a statistical genius. He created the ORSO model, the Oregon Sea Otter model. So with all the data that we have, you could go to a website, put in how many sea otters you want to be released, say, in Cape Arago. And over a 10-year period, it would tell you the likelihood of success of that population. And so now we have an updated version that includes Northern California. They are doing the finishing touches on a paper publication showcasing this. So it'll be out soon, but based on that model, it's about 152 or so sea otters to be released. So that is the magic number. And where would we get them from? Great follow-up question. So, we know that 90% of the global population of sea otters live in Alaska, and those are northern subspecies. And so, U.S. Fish and Wildlife Service is the entity that manages marine mammals, sea otters specifically. So, they would be the ones to pick what population they would get. And so, northern subspecies of sea otters has such a high number that their genetic diversity is very high, and so they're not listed as threatened under the Endangered Species Act. But those sea otters off the coast of California, the southern subspecies, cannot intermingle. They are blockaded where they are located right now. So they cannot expand. They kind of have already hit their carrying capacity. So, with a low genetic diversity, they are listed as threatened. So, that means there's a lot more red tape and legality to jump through hoops to capture them and reintroduce them somewhere else. But I think the best balance of that would be to capture them from Alaska, reintroduce them on the Oregon coast, and then over several years, reintroduce surrogate raised southern pups into that population that the Monterey Bay Aquarium, the Long Beach Aquarium, and SeaWorld San Diego all have these surrogate moms in the background of their facilities that raise pups that are stranded in the wild. These surrogate moms teach those pups how to become a little baby sea otter in the wild without human intervention. And then they release those pups in about 6 months to see if they can make it on their own in the wild. They document them for about 2 weeks. If it seems like they're doing okay, then they are in the wild for good. And if they don't seem, if they're coming up to humans or anything, then they recapture them and try and do some more rehab and try and release again. And if it turns out they can't be deemed releasable, then those baby sea otters get sent to an accredited zoo or aquarium. So there is no captive breeding of sea otters in a zoo or aquarium because there's so many stranded pups that often are deemed unreleasable because they are several days old and need a lot of human care, especially in Alaska, that if there's not a place for them to go, then they will have to be euthanized.
Okay, we have time for one more question, and it looks like Sarah has up there, and I'm not sure if you had answered this. Is there thoughts that the two subspecies could successfully reproduce and hybridize? If is there evidence for this?
Yes. Hold
Good.
on. I'm just putting a link in our merch for Deborah.
Oh, somebody
Um,
already did that. It looks
oh,
like,
oops,
yeah.
sorry.
No, no,
Beat
they
me
did
to it.
that for you. Yep.
Thank you, Brenda, for doing that. So great question. There are really no differences genetically between all the subspecies. They're only subspecies because they're geographically separated. So they were one continuous, pretty much population across their native range, but now the ones in Japan are very isolated, and the ones in Russia are isolated, and the northern subspecies are only in Washington and north, and the California range can't expand anymore. So that's why they're a subspecies. So there's nothing blocking them from intermingling with each other when that time comes successfully.
Well, thank you so much, Chanel. We appreciate your time that you spent with us this evening.